All right, so hello everyone, and thank you for joining. My name is Daniel Weinberg, and I'm the product manager at Contel Smart Energy. Today, I'd like to talk about a topic we encounter in every almost renewable energy project: is how modern SCADA is evolving from a system that displays data into a system that supports operational decision making. We'll explore why traditional SCADA approaches are no longer sufficient, how different users consume the same operational data in different ways, and what it takes to build a scalable platform that serves all of them effectively. So before we dive in, let me briefly introduce Contel Smart Energy. We are part of the Contel group with more than 60 years of experience in industrial automation, electrical system, control systems, in the renewable energy. Contel Smart Energy, which is a subsidiary of Contel, provides an Energynie platform which manages and monitors PV sites, battery storage system, hybrid of both PV and storage, and grid connection, of course. All right, so the central challenge is the data alone is not create value. The same inverter may be viewed by 5 different users, and each of them needs something completely different. So, for example, the operator wants to know whether the site is stable and operating safely. The technician wants to know what needs to be fixed, while the engineers wants to understand the root cause. And of course, the business unit and the site manager want to know the potential financial risk and risk to performance. So before I dive in on how we solve this, just a quick word about our approach building Energynie. Traditional SCADA systems were developed using the waterfall approach, as you can see on the right side of the screen. Requirements were defined upfront, developed followed by a fixed plan, and feedback typically arrived late in the process. As user needs and renewable energy operations became more dynamic, this approach became harder to scale. This is why we chose to lead the development process by using agile product approach. Instead of long development cycles, we deliver frequent updates, gather continuous user feedback, and constantly improve the platform. The goal is simple: ensure the product evolves with the customer needs and achieve strong product market fit. The first requirement of any operational platform is understanding what is happening right now. Users need immediate visibility into site status at the portfolio level for equipment availability, active faults, or production performance. The goal is not to show everything. The goal is to show the information that mattered the most at the moment decision need to be taken. So let's dive into Energynie. We chose to present the dashboard as a tile-based UI. Each tile presents different side and can be pinned to the top or removed from display. The user can also sort the board by type, by status, by size of the site. Additionally, we are allowing the user to control the amount of data presented in each tile. For example, as you see right here, in X2, we are just indicating the status of the inverters, which is a major KPI in site production, while in X3, each inverter is presented separately on the screen, as you can see right now. The dashboard have another version for more traditional view, for a table alongside with a map indicating site's location. You can see it right now. The map can also configure to different style, really depends on the user preference. Once users understand what is happening, the next step is allowing them to consume information the way that best supports their role. The same operational data can be presented through a solution we develop inside Energynie, such as widgets, reports, trends, saved analysis, or the BI tool. Each tool serves a different purpose. The objective is to provide user with the most effective way to access information based on their workflows and responsibilities. In this video, you can see how user personalize the experience within Energynie. This is example of a PV site overview screen. Using Ignition's component architecture, we build a widget-based framework that combines fixed operational widgets with dynamic user-selected widgets. The fixed user widgets ensure consistent operational experience across the organization, while dynamic widgets allow users to tailor their workspace. This approach allows us to create a single platform that serves multiple user types without requiring multiple SCADA application. Moving to reports, customers wanted a simple way to review operational KPIs without having to manually collect the data. To address that, we leverage the Ignition reporting module and build a library of pre-configured reports. User can select the desired time range, the data sampling interval, while maintaining constant reporting structure across all sites. This is our trends module. This is one of the most important tools for engineers. So we decided in this case too to build on top of the Ignition trend model and extend it based on customer feedback. One challenge we identified was the effort required manually add tags. To solve this, we developed a tag grouping mechanism that allows user to select multiple tags with just one click. Also, to improve readability, we enhanced the visualization options for single pens and made it easier to compare multiple tags. As you can see right here, I'm choosing bar instead of graph, and I can change the color into purple. By clicking done, you're gonna see it. Finally, users can also save these trends either for personal use or to share them across the organization. This allows the engineering knowledge of the company and best practices to be reused across multiple sites. This is like an example of how can I upload a new trend, save trend. If you want even more flexibility, this is our BI tool. Unlike a predefined SCADA screen, user can select any tag, and by using this drag and drop interface, creating new widgets. Each widget can have its own time range and display settings, allowing user to change the way the data is presenting without rebuilding the entire dashboard. So far, we focused on visibility and understanding. The next thing is enabling action. Energynie offers 3 capabilities for control. The first is Smart Scheduler, Forecast Mode, and Recipe Wizard that help user plan activities and manage site behavior in a structured way. One of the challenges our customer faced was the need to perform the same operational actions repeatedly. The idea is simple. User configure operational logic once, and as you can see right here, the Smart Scheduler module. Once you create it, from that point, the process runs automatically according to the defined schedule. In forecast mode, as you can see right here on screen, renewable energy operations became more dependent on forecasting and market participation. Customers need to understand what is happening, but also wanted what should happen. To support this, we developed an algorithm that automatically generates the site production plan based on available operational data and forecast data. Forecast mode allowed the users to compare 3 different perspectives in a single view: the plant production and the actual site production, and of course the forecast data. Recipe Builder, this is what the video was a little bit running. Recipes allow user to predefine operational scenarios and can be executed whenever needed. Instead of manually configuring like Smart Scheduler the settings, operators can reuse approved operational templates with a single action. This reduces human error and helps standardize best practices across multiple sites. So as you can see, I'm choosing the recipe name and description, decide when it's gonna work, the days of the week it's gonna work. And here I have my recipe warehouse. I can choose when I want to activate them. I can also edit these recipes. And I have logs for investigating. And we are also presenting in like an Outlook style. So if I need to summarize everything we discussed into 3 key principles. First, platform before customization. Build a scalable foundation first and then adapt it to individual customers and sites. workflows before features, design around real operational process, and not around isolated functionality or feature. And last, users before screens. Start with the user journey, the person making the decision, understand their objectives, and then design the interface that supports those decisions. All right, so thank you very much for your time and attention. If you'd like to connect through LinkedIn, this is a QR link to my profile. Thanks again.